In this example, we're going to do a little more exploring of the distribution of the sample mean. And so what we're going to look at is the Hollywood Movie 2E budget data that's built into StatKey, which has a population size of 897. And what we want to do is look at generating 3,000 different samples of sizes 5, 3,000 samples of size 20, and 3,000 samples of size 50, and get a feel for where are they centered at, what's their standard error, their spread, and what shape are we seeing in these different distributions. So if we go over to StatKey and we have that data set built in, we're going to first look at sample of size 5. And I'm going to generate 3,000 samples by clicking the Generate 1,000 Sample button 3 times. So if we look in this upper corner of the box where we have all the dots, we see we have 3,000 samples. Their mean is 56.543, and our standard error is 23.906. The mean there is pretty close to the actual population mean that's over on the right-hand side of 56.117. What we are also seeing, if we look at the shape of that distribution, is that it does in some way mimic the original shape of the distribution, where we have a tail to the right, so we have that right skewed shape. Now, what we want to look at is what happens if we change the sample size slightly. So what if we take, instead of samples of size 5 and find X bar for each sample size 5, what if we take samples of size 20? We'll do it 3 times again. So we have 3,000 samples. The mean of the 3,000 X bars that we have here is 56.110. Again, close to the original population mean of 56.117. And our standard error has dropped down to 11.798. And we still have a little bit of a tail on the end, so still a little bit of a right skew going on here. Lastly, if we bump the sample size up to 50 and look at that, we will see that we are centered at 56.286, so again, still close to 56.117. Our standard error dropped again to 7.426, and what we have for a shape here now is more symmetric. So the trends that we're seeing is that the mean of the 3,000 X bars is always close to the actual population mean. The standard error is dropping or decreasing as n gets bigger, and the distribution is becoming more symmetric as we take a bigger sample size.